A very good morning to all of you. Once again, I welcome all of you in today's practical. In the last practical, we were conducted the practicals on study of hydraulic jump. Okay, and in case of the hydraulic jump, we have determined the various hydraulic parameter, that is length of the jump, height of jump, then loss of energy due to the formation of hydraulic jump. Then also we have determined the D1 and D2 before and after formation of the hydraulic jump. Okay. So in the today's practical, we are going to conduct second practical, and the second practical is on the calibration of notches and weirs. Okay. So what is notch and what is weir? Notch is a metallic structure which is constructed across the channel for measuring the discharge. Okay. And weirs are the masonry or concrete structure which is also constructed across the flow in open channel for measuring the discharge. Okay. So how the discharge is measured with the help of these particular notches and weir, we are going to determine in today's practical. Now before conducting the today's practical, it is equally important that we should know why one should determine the discharge in the open channel. Okay. Can anybody tell me why one should determine the discharge in the open channel? Yes? Anyone? Why one should determine the discharge in the open channel? Nilesh Suryavanshi. Nilesh?
Yes, sir.
चॅनल मधला डिस्चार्ज का बरं डिटरमाइन करायचं? Why one should calculate the yes
For the purpose of irrigation.
for the purpose of irrigation. Okay. Aniket?
Yes. Good morning.
Why one should determine the discharge in the open channel?
To measure the capacity of channel.
Okay. Now see here, for example, we have a channel. Okay, we have a dam. So through the channel, okay, we have to supply the water for the irrigation purpose. Okay. So some farmer is having 2 acre, some farmer is having 5 acre field. Okay. So depending upon the irrigations. Okay. For example, how much water we required for 2 acre irrigation. Okay. Then for 5 acre irrigations, how much water we required. So such kind of, you can say, the channel we required for supplying the water in case of the irrigations. Okay. So I am going to share with all of you the today's presentation. Wait 1 to 2 minutes. So I am going to share with all of you the presentation.
Grammarly helps make your writing clear and
So-
concise, no matter where you are. Compose a cover letter that...
See here, for example, we have a dam, and by opening the dam gate, we have to supply the water. So in the channel, it is very equally important that we have to measure the discharge, okay, and by measuring the discharge, we can supply the water for irrigation according to the area to be irrigated. Now let us see here, this is a channel, okay. Through this channel, the water is flowing, okay. Now it is very important that we have to measure this water, okay. So the discharge through this channel, meter cube per second or liter per hour, okay. So this is how the water is flowing in the particular channel, okay. And our responsibility is that you have to measure the discharge. So in the today's practical, we are going to measure this particular discharge, okay, how much water is flowing through this particular channel, so as to we can supply the sufficient quantity of water for the irrigation purpose to the crops, okay. For example, we have a field here. Now by measuring the discharge in the channel, we have to, for example, one farmer is having 2-acre field, another farmer is having 5-acre or 10-acre. So depending upon the area to be irrigated, we have to supply the water through this channel, okay, to this particular field, and we have to collect the water charges, okay. So the government will collect the water charges according to the rate of supply for the irrigations. So this is the important things we are going to determine in the today's practical as far as irrigation concerned. So we have the uh, virtual lab, okay. With the help of this virtual, we are going to determine the discharge through the channel. So first, I would like to ask any one student, okay. Sumit Shikre is there. Sumit Shikre. Sumit. Sumit. Pradnya Sonavne. Pradnya. Pradnya Sonavne is there. Yes.
Yes, sir.
So can you read this? This yes.
A notch is a device used for measuring the rate of flow of a liquid through a small channel or a tank. It may be defined as an opening in the side of a tank or vessel such as liquid surface in the tank is below the level of opening. Notches can be of different shapes such as triangular, rectangular, trapezoid, stepped notch, etc. The bottom of the notch over which the water flows is known as crest or seal, and the thin sheet of water flowing through the notch is known as nope or vein. The edges of the notch are beveled on the downstream side so as to have a sharp edges side and crest, resulting in minimum contact with the flowing flood.
Okay. So what is mean by the notch? Okay, notch is a device. It is used to measure the discharge or the rate of flow through a small channel. Okay, small. Okay, so the notches are having the different types, that is triangular, rectangular, trapezoidal or step notch. Okay, so let us see, here we have a channel. So this is a rectangular channel. Okay, and at a point, at a selected location, we have to fix a notch. Okay, so this is the shape of the notch. Now we have the length of the notch here, and this is the total height of the notch. So this is known as the crest level. This is the this bottom level of the notch is crest level. So we have to fix this notch across the flow. Across the flow means at an angle 90 to the flow. Okay, where we are going to measure the discharge. Okay, so we have to fix this notch here. Then the classification of the notch, we have a rectangular notch. Okay, so this is the shape of the rectangular notch. Then we have a trapezoidal notch. Okay, in case of the rectangular notch, this is the head above the chin level or the crest level. Then in case of the trapezoidal notch, so above the chin level or the crest level, we have to measure the head. Okay, then we have a triangular notch also. So this is the shape of the triangular notch. This is the theta. Okay, angle of the triangular notch. So this is the sea level, and we have to record the head above the sea level, that is capital H. Then we have the step notch. So these are the different step. Okay, so for the first step we have the width b1, b2, b3 as far as concerned with the 1, 2 and 3 steps, and then also we have h1, h2, h3, that is the head for the step notch 1, 2, 3 etc. Okay, now how to measure the discharge for a rectangular notch? Okay, so we have the formula. Theoretical discharge is equal to 2/3 CD L root 2G H raised to 3/2. Okay. Then for the triangular notch, if you do the derivation, so we will get 8 by 15 CD tan theta by 2 root 2 G H raised to 5 by 2. Okay. So that is the formula for triangular notch. In case of trapezoidal notch, it is the combination of rectangular notch and trapezoidal notch. Okay. You have to add these two formulae, you will be get the discharge through the trapezoidal notch. Okay. So this is about the notches and weir. Okay. So the notches and weir are the arrangement made across the channel to measure the discharge. Okay. So this is about the notches and weir. Now I am going to discuss the step-by-step procedure how to measure the discharge with the help of the triangular notch and weirs. So I am going to start the droid cam. So it requires 1 minute. Okay. So I am going to start here a droid cam. Okay. Now, how to measure the discharge with the help of triangular and weir. I am going to discuss that practical. Now the aim of the today's practical is calibration of notches and weir. Okay, calibration of notches and weir. That is the aim of today's practical. Calibration of notch or weir. So we have a Ogee weir. Ogee weir is nothing but a rectangular weir. Okay. So how to conduct the practical? So for that purpose, we required a channel. Okay. So we have a channel. So this is the L section. Okay. This is the channel. This is the bed of the channel. This is channel or canal. Okay. Now at the end of this channel we have a measuring tank. Okay. So this is measuring tank. This is measuring tank. Okay. And on one side of measuring tank we have a piezometer to measure the rise of water level in the measuring tank. Okay. Now, for example, the channel is rectangular. Okay. So this is the channel, rectangular channel. We have to fix this notch or weir at anywhere in the channel section. For example, if you want to measure the discharge at this particular location or at this particular locations. Okay. So this is section 1.1 and this is section 2.2. For example, first if you want to measure the discharge at section, So you have to construct notch and weir across the flow at this section. Okay. So I am going to construct the rectangular notch or weir. So this is the rectangular notch or weir. Okay. Now here we have the seal level or the crest level. Okay, this is seal level or crest level of the rectangular notch. Rectangular channel with a rectangular notch. Okay, rectangular notch. Now we require certain observations. Okay, we require the observation for practical observation. So we required width of the channel, so B is equal to 0.09 meter in case of our laboratory. Then dimensions of measuring tank, we require the observations. Dimension of measuring tank, MT means measuring tank, L into B. So the length is 0.3 meter and the width is also 0.3 meter. Okay, length is 0.3 meter and the width of the measuring tank is 0.3 meter. So these are the observation we required. Now we have the observation table. Okay, we have the observation table. Okay, we require the observation table. So in case of the observation table, serial number. Okay, serial number. Then the second one is head above crest level or the seal level, that is capital H in meter. Then the third column, that is rise of water level in measuring tank, that is a small h in meter. Okay, then time taken to rise water level in measuring tank, that is T in second. Okay, so time taken to rise the water level in measuring tank. Then the fifth column, actual discharge, that is Q actual in meter cube per second. Okay, then the next column for Q theoretical discharge, and lastly we have to find out coefficient of discharge, that is CD. So look at the observation table. We have the serial number. In the first column we have the serial number. Then for the second column we have the head above the crest level in the channel. Then rise of water level in the measuring tank H, and the time taken to rise the water level in measuring tank. Then we have to compute the actual discharge, then we have to compute theoretical discharge, and then we have to compute the coefficient of discharge, that is CD. Okay, so let us try to understand this practical step by step, how we are going to conduct this particular practical. So first, what we need to do, we need to open the dam gate. Okay, for example, we have a dam here. Okay, this is a dam, and here we have the gate. Okay, so this is the gate. Okay, this is dam gate. Okay, this is dam gate, and on the upstream side of the dam we have a water. This is a dam. Okay. Now, if you want to supply the water for the irrigation purpose, then what we have to do? We have to open the gate. Okay, we have to open the gate. So, how much gate we have to open, for how much height we have to open, that is depends upon the area to be irrigated. ओके, म्हणजे किती जमीन आपल्याला पाण्याच्या खाली आणायची आहे, किती जमिनीला आपल्याला पाणी द्यायचं आहे, किती शेतीला पाणी द्यायचं आहे, त्याच्यावरून किती गेट ओपन करायचं ते डिसाइड होतो. फॉर एक्झाम्पल, इफ यू वांट टू इरिगेट 10,000 hectare field, so we have to open accordingly and we have to release the discharge. So now the discharge is released through the channel. Okay, the water is now flowing through the channel. Okay, so here in case of this particular video, okay, in case of this particular video, if you see here, by opening the gate we have to supply the water in this way. Okay, now see here, we have to supply the water, and then we have a field here. Okay, and through this channel we have to supply the water for different crops. Okay, and we have to measure at any location how much discharge is flowing. Now see here, we have again small channel. This is known as water course. आता let us see here, this is the main canal. Okay, this is the main canal, and we have a water course. आता याच्यामधून सुद्धा आपण डिस्चार्ज मेजर करू शकतो. The water course, the design of this water course is according to the area to be irrigated. किती पाणी द्यायचं आहे शेतकऱ्याला त्याच्यावरून याचं डिझाइन डिपेंड राहतं. ओके, so we have to also record the discharge in the water course also. Okay, so see here, now the water is flowing through the water course and it is coming to the field. So we have a crop here. Okay, so we have a crop here, that is rice crop. Okay, somewhere another crop will be there. So depending upon the types of the crop, we have to supply the water through the water course. So this is a water course. Now again we have a water course. See here, and in this water course also we have to measure the water. We have to measure the rate of flow or the discharge, how much water is flowing through this small channel. Okay, now या स्मॉल चॅनल मधून सुद्धा ओके किती पाणी वाहतं ते सुद्धा इक्वली इम्पॉर्टंट आहे. सो वी हैव सप्लाइड द वाटर फ्रॉम दिस चैनल. Okay, now when the water is coming at the notch, this is a rectangular notch. Okay, now what will be happening, the water is rising above the crest level. Okay, and we have to measure rise of water level, that is the head above the sea level. समजा आपण 1/4 गेट ओपन केला तर मग पाणी या नॉच पर्यंत येईल आणि मग नॉचच्या मधून पाणी जाईल आणि त्याच्यावरती ही सी लेवल आहे, याच्यावरती हा हेड बनेल. हेड मीन्स द हाईट ऑफ वॉटर अबोव द सी लेवल. आणि आपल्याला हीच रीडिंग तिथं घ्यायची असती जिथं आपण नॉच अँड वियर बनवलेला आहे. समजा मी इथं लोकेशन दाखवलं, इथं आपण अक्रॉस द फ्लो, तर या सी लेवलवरून या हाईटला पाणी याच्यावरून जाईल. तर वी हॅव टू रेकॉर्ड दिस हाईट and we have to, for example, the 20 centimeter the head of water above the crystal level we have recorded for the first reading, that is 0.2 meter. Okay. Now once the head is above the crystal level we got, then we have to measure the time taken to rise the water level in the measuring tank also. आता इथं काय होईल, now what is happening, the water is coming in the measuring tank. ओके. आता इथं आपल्याला मुद्दा मराठीमध्ये सांगतो, इथं आपल्याला हा जो राईज आहे स्मॉल एच, ओके, इथं स्मॉल एच आहे, तो आपण 0.2 मीटर ॲझ्युम करू. तुम्ही 15 सेंटीमीटर सुद्धा ॲझ्युम करू शकता, 10 सेंटीमीटर और 20 और 25 और 30. तर आपण इथं आता 0.2 मीटर दॅट इज 20 सेंटीमीटर ॲझ्युम केलेली आहे या टँकमध्ये हाईट. नाव वेन द वॉटर इज कमिंग इन द टँक फ्रॉम द चॅनल वी हॅव टू स्टार्ट द स्टॉप वॉच. आता जेव्हा या मेजरिंग टँकमध्ये पाणी पडेल चॅनलमधून, तेव्हा आपल्याला काय करायचं आहे, स्टॉप वॉच लावून द्यायची आहे. कधीपर्यंत स्टॉप वॉच चालू ठेवायची, जोपर्यंत पाण्याची लेवल 20 सेंटीमीटर पर्यंत येईपर्यंत. जेव्हा 20 सेंटीमीटर राईज आली, दॅट कॅन बी सीन बाय द पिझोमीटर. पिझोमीटरने आपल्याला कळतं की लेवल कितीपर्यंत आली. जेव्हा 20 सेंटीमीटर पर्यंत लेवल आली तर स्टॉप वॉच बंद करायची आणि तो टाइम इथं लिहायचा. सो रेकॉर्ड दी राईज ऑफ वॉटर लेवल इन द मेजरिंग टँक. आपण आता इथं 20 सेंटीमीटर घेतली, दॅट इज 0.2 मीटर. आणि मग इथं टाइम किती लागलं ते राईज होण्यासाठी मेजरिंग टँकमध्ये, वी हॅव टू रेकॉर्ड दॅट. ओके. सो दी टाइम टेकन टू राईज द वॉटर लेवल इन द मेजरिंग टँक इज 40 सेकंड. ओके, 40 सेकंड लागले. नाव वी हॅव टू कॅल्क्युलेट ॲक्च्युअल डिस्चार्ज अँड theoretical discharge now. Okay, so we are going to do the sample calculation. Okay, so the sample calculation, now if you see we have the sample calculation. The next one is sample calculation. I request all the students, please be ready with your calculator, so you can do the sample calculation simultaneously. Okay, so we have the sample calculations. Okay, sample calculations. So the first sample calculation, we have to measure actual discharge. Actual discharge. Okay, that is Q actual. Okay, so we have the formula for Q actual. Volume of measuring tank, empty means measuring tank divided by time. So the volume of measuring tank is L into B into H divided by T. So length and breadth is given in the observation, that is 0.3 meter by 0.3 meter. आणि ही rise आपण consider केलेली आहे. The rise we have considered, that is 0.2 meter divided by the time taken to rise the water level in the measuring tank, that is 40 seconds. Okay, that is 40 seconds. So calculate Q actual. How much is the actual discharge? Anybody can tell me?
4.5 into 10 raised to minus
4.5. Okay, 4.5 into 10 raised to power minus 4 meter cube per second. Okay, so this is how we can measure the actual discharge. So once we have the actual discharge, then the second sample calculation we have to do, that is theoretical discharge. Okay, theoretical discharge, we have to calculate theoretical discharge, that is Q theoretical. Okay, so theoretical discharge and actual discharge. Actual discharge means it is the discharge calculated by performing and practical. Practical केल्याच्या नंतर जे डिस्चार्ज येतं त्याला म्हणतो आपण actual discharge. आणि theoretical discharge म्हणजे काय? The discharge which is calculated by using various formulae. Okay, that is known as the theoretical discharge. So for rectangular notch or weir, we have the formula. Okay, so anybody can tell me what is the formula for theoretical discharge by rectangular notch or weir? Yes, what is the formula? Anybody unmute yourself and tell me. काय फॉर्म्युला आपण काढलेला आहे रेक्टँग्युलर नॉट साठी? यस, एनीबडी? बोला, काय फॉर्म्युला आहे? आता theoretical discharge rectangular, now for rectangular notch, okay, for rectangular notch, so third L, आता इथं CD नी घ्यायची, CD नी घ्यायची इथं, ओके, कारण आपल्याला कोएफिशिएंट ऑफ डिस्चार्जेस काढायचा आहे. सो 2/3 L रूट 2G H raised to 3/2. Okay, so 2/3 L root 2G H raised to 3/2. So 2/3, this is the length of notch. Okay, so the length of the notch is given 0.03, that is 3 centimeter. Okay, the length of the notch is 3 centimeter, for example. So we have to take the length, then under root 2 into 9.81 into H raised to 3/2. So we have taken H. आता आपण इथं हेड घेतलेला आहे. आता हे बघा, इथं आपण हेड कॅल्क्युलेट केलेला आहे. ओके, दॅट इज 20 सेंटीमीटर. हेड अबव द क्रिस्टल लेवल हा आपण मेजर केलेला आहे. ओके, फॉर कॉन्स्टंट डिस्चार्ज किती आलं ते 0.2 मीटर. सो 0.2 raised to 3/2. So calculate here Q theoretical. Calculate करा किती आला? Tell me how much is the theoretical discharge? Yes, 2/3 into 0.03 into root 2 into 9.81 into 0.2 raised to 3/2. आणि सगळ्या विद्यार्थी, यस,
7.92 to 10 raised to minus
7.92 into
10 raised to minus 3.
10 raised to power minus 3. अजून कोणी बोलू शकतो? यस, एनीबडी एल्स? हे बघा, इतकं वेळ तुम्ही लावणार ना, मग प्रॅक्टिकल होणार नाही सगळे, बरं का. यू डोंट टेक सो मच ऑफ द टाइम. दॅट इज युअर रिस्पॉन्सिबिलिटी फॉर कॅल्क्युलेशन. ओके, आता मी नाव घेतो. ओके, सो प्लीज टेल मी. Please tell me. Pawan is there? Pawan Sudke? Pawan Sudke is there? Aniket?
Yes, sir.
किती आलं?
Sir, 7.92 into 10 raised to minus 3.
Okay. कैलाश शिंदे? कैलाश शिंदे? कैलाश शिंदे is there? काय अभ्यास करणार आहे बाबा तुम्ही? डिप्लोमाचे आहे का सगळे? यस, अनिकेत? बिफोर बॅच मध्ये सगळे डिप्लोमाचे आहे का?
Sir, मी डिप्लोमाचा.
म्हणजे सगळे डिप्लोमाचे असेल नाही B4 बॅच मध्ये आय थिंक. हे बघा असं केल्यावरती काही अभ्यास होणार नाही बरं का. यू हॅव टू डू द कॅल्क्युलेशन फास्ट. आणि फक्त मोबाईल लावून काही उपयोग नाही. प्रज्ञा सोनावणे, प्रज्ञा सोनावणे, प्रज्ञा सोनावणे इज देअर. साई प्रसाद, साई प्रसाद, निलेश, निलेश सूर्यवंशी.
Yes, sir.
How much is the theoretical discharge? Yes, can you tell me? Calculation करू शकता तुम्ही? Remember, if you doing such things, that is very bad things. Okay? सगळे डिप्लोमाचे आहे आणि मग डिग्रीच्या नंतर सुद्धा अशीच जर पोझिशन राहिली तर कोणी जॉब तुम्हाला देणार नाही. ओके. So what should be the theoretical discharge? Yes. इतका वेळ लावताय एका कॅल्क्युलेशन साठी. Yes.
सर ते एल 0.3 पाहिजे सर म्हणे.
0.03 3 सेंटीमीटर आहे ते.
यस.
यस. किती आलं मग?
7.92 into 10 raised to minus 3.
7.92 into 10 raised to power -3 मीटर क्यूब पर सेकंड. भरपूर वेळ लावता तुम्ही आणि अशी पोझिशन असली तर मग कॅल्क्युलेशन मध्ये एवढं, अरे तिथं तर फास्ट पाहिजे कॉम्पिटिटिव्ह एक्झामिनेशन मध्ये. ओके. दिस इज व्हेरी. Now the next things we have to calculate coefficient of discharge. Okay, we have to calculate coefficient of discharge, that is CD. Okay, so CD is equal to, it is the ratio of actual discharge to the theoretical discharge. Okay, so CD will be actual discharge by theoretical discharge. So CD will be, actual discharge is 4.5 into 10 raised to power minus 4 divided by 7.92 into 10 raised to power minus 3. So what should be the CD? किती आली? Anybody?
22.72 into 10 raised to 3.
किती आला CD ची व्हॅल्यू? हे सगळे डिप्लोमाचे आहे का रेग्युलर आहे या बॅच मध्ये?
सर 0.05 6
0.05
6.
0.056. Okay, so this is the value for the CD. Now we have to substitute here. Actual discharge is how much? 4.5 into 10 raised to power minus 4. Then theoretical discharge is say 1.92 into 10 raised to power minus 3.56. Okay, is the CD. So this is how we can determine the coefficient of discharge for the first setup. Okay. Now by the virtual lab, okay, we have a virtual lab also. आता इथं तुम्ही प्रॅक्टिस करू शकता. Okay, in case of the virtual lab. Now the virtual lab is designed by the MHRD Government of India, okay, through the various IITs. Now in this case, in the virtual lab, हे ऑनलाइन आहे, तुम्ही पण सर्च करू शकता याच्यामध्ये आणि प्रॅक्टिस करू शकता. ओके, so see here how we can measure the coefficient of discharge by the rectangular notch, for the rectangular notch. So before that we have a quiz here, because we have completed the calibration of rectangular notch. So I am going to ask question. आता हे तुम्ही वाचायचं आहे. पवन सुडके, पवन सुडके इज देअर. पवन सुडके, पवन सुडके आहे का? निलेश सूर्यवंशी.
Yes, sir.
Now you have to read the first question and tell me which with the all option, and tell me which option is correct. Read the first question with option and tell me which option is correct. Okay.
For this respiratory rectangular weir, an arrangement for aeration of nappy is necessary. Option first, to maintain water quality, to prevent submergence of the weir, to have the highest value of CD, to have a constant head discharge relationship which is independent of time.
Yeah. So have you understood this particular question?
Yes, sir.
So please tell me which option is correct.
To maintain water quality.
Anybody else? Yes.
Sorry, D option.
Which you have to read that option.
To have a constant head discharge relationship which is the independence of time.
Okay. So that is the correct answer, I think, because see here, for a suppressed rectangular weir, an arrangement for aeration of nape is necessary. What do you mean by aeration of nape? Nape means the jet. Okay. For example, see here, I am going to explain this particular. So we have this weir. Okay, this is a weir. Okay. So when the water is flowing above this is a crest level. Okay. Now when the water is flowing above this crest level and coming at the bottom, okay, coming at the bottom, so this is called as NAPPE. This is called as NaPe, nape of water or the jet of water. Okay. So for a rectangular weir, an arrangement for aeration of nape. Aeration means this water jet is in contact with the atmospheric air. एरिएशन म्हणजे काय, त्याला चांगली हवा भेटायला पाहिजे. ओके. एरिएशन इज नोन एज the nape of water or jet of water is in contact with the atmospheric air. तिथं त्याला atmospheric air भेटायला पाहिजे जेव्हा या वियर वरून पाणी खाली पडेल. ओके. So the is correct to have a constant discharge relationship which is independent of time. Okay. If you check the answer, this is the correct answer. Now next one is anybody unmute yourself and read this question with all the options. Yes. Anybody? Yes.
The sheet of liquid flowing over the notch is known as, first option, nip, second option, seal, third option, crest, fourth option, none.
So which option is correct?
Crest.
Yes. No. See here. Earlier I have told you इथं क्रिस्ट लेवल आहे, ही क्रिस्ट लेवल म्हणजे त्याचा शेवटचा पॉइंट म्हणजे क्रिस्ट लेवल आणि सील लेवल. ओके. सील किंवा आपण याला म्हणतो क्रिस्ट लेवल. ओके. तर या क्रिस्ट लेवल वरून जेव्हा पाणी पडतं तर त्याला काय म्हणतो आपण, द शीट ऑफ लिक्विड फ्लोइंग ओव्हर ए नॉच इज नोन एज, सी दिस इज नोन एज नेप. ओके. That is the correct answer. Then anybody? Pradnya Sonavne. Pradnya is there?
Yes, sir.
Pradnya, yes. Please read the third question with all option and tell me which option is correct.
A notch is a device used to measure first rate of change of flood through small channels, second rate of change of flood through large channels, third
This is
rate of
fluid. This is fluid, not a flood. This is fluid. Fluid may be the water. Okay.
change of fluid through any type of channels, fourth none of the above.
So which
Rate
option
of
is correct?
third rate of change of flood through any type of channel.
That is not a flood again. You have to do the correct pronouns. That is fluid. 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 Fluid means it is a in the form of water or any types of the liquid. Okay. That is known as the fluid.
Yes, sir.
So can anybody tell me which option is correct? व्हिडिओ मध्ये सुद्धा आता बघितलं तुम्ही याचा आन्सर. Yes. Which option is correct? Anybody? Anybody else? इतकं वेळ कशाला लावता रे तुम्ही? कैलाश शिंदे. कैलाश शिंदे is there? कैलाश शिंदे. Yes. Sai Prasad. Sai Prasad is there. Sumit Shikre. Sumit.
Yes, sir.
Which option is correct for this question? Sumit. Yes.
Sir, I think second. Second.
अरे आता बघितलं ना आपण, द रेट ऑफ चेंज ऑफ फ्लुइड थ्रू स्मॉल चॅनल. ओके.
Okay. Sir.
Now Sumit, read this fourth question with option and tell me which option is correct. Read question with all the option. Sumit. Unmute yourself. Read the fourth question with all the option and tell me which option is correct.
When water flows over a rectangular space,
Yes.
the negative pressure created beneath the nap. Option is dissolve the discharge, increase the discharge, does not affect the discharge. None of this.
Sumit, you are from diploma?
No,
Yes.
sir, I'm regular.
You are regular. Okay. So tell me which option is correct. Yes.
Increase the discharge.
Increase the discharge. Right answer. Then this is also we have completed in case of the notch and weir, most economical rectangular channel section. Aniket,
Yes, sir.
please read this question and tell me which option is correct.
For most economical rectangular section of a channel, the depth is kept. The first option, 1/4 of width, 3 times. Second, 3 times the hydraulic uh, radius, 1/2 of the width. Fourth option, hydraulics mean depth.
Hmm. So for most economical rectangular channel section, the depth is kept.
Sir, third option, 1/2 of width.
Yes. That is the correct one. Right answer. Okay. So in case of the laboratory, we have such kind of the test. Okay. So in each experiment, there will be a 5 to 6 question, and this question is very important for the competitive examination point of view also. So you have to Google it. That is the virtual lab. So you will find that such kind of lab will be there, and you have to practice. So again, we have the assignment here, and it is expected that you have to do this particular assignment. We have the assignment questions also. Draw different types of the name. Okay. Then the second questions in case of the assignment is that derive the expression for discharge over a rectangular notch. Then what is ventilation of weir, why it is required, and the fourth question. And in case of the theory also, we have all the questions. So prove that error in the discharge due to the error in the measurement of height over the rectangular notch is dq by q is equal to 3/2 dh by h. 3/2 means 1.5 dh by h. So we also prove that in the theory. We also derive the expression for discharge through the rectangular notch, that is 2/3 CDL root 2GH raised to 3/2, and also we have proved this sentence, that is dq by q which is equal to the 3/2 dh by h. Okay, error in the discharge due to the error in the measurement of head. जर हेड मध्ये जर आपण चुकी केली मेजरमेंट करत्या वेळेस तर डिस्चार्ज मध्ये काय चुकी होऊ शकते हा आपण डेरिवेशन मध्ये सुद्धा बघितलेला आहे. ओके, so this is how we can complete the experiment, that is the calibration of weirs. Okay, so I declare that today's practical is over. You may leave now.